Okay, so let's look at some examples for week 10. All right, so this is just out of the chapter. So number 4 is the 10 most active stocks in the New York Stock Exchange on March 6, 2006 are shown here. AT&T, Lucent, Nortel, Quest, Bell South, Pfizer, Texas Instruments, General Electric, uh, ISHR, MS, Japan, LSI Logic. So the exchange authorities decided to investigate trading practices using a sample of 3 of these stocks, beginning with the first random number in column 6 of table 7.1, which is on the next page here. Read down the column to select a simple random sample of 3 stocks for the exchange authorities. Then B, using the information in the third note and comment, determine how many different simple random samples of size 3 can be selected from the list of 10 stocks. All right, so let's see here. We're supposed to go into column 6, and we need to go over here, and then we count down. So we have 5, 0, 5 repeats, so we're going to have to throw that out, and so then we go to 8. And so 5, 0, 5, 8. And what does that represent? Well, they usually go across the numbers, so 1 through 5 here, and then 6 through 10 here. So fifth one would be Bell South. And then 0 would count as 10, so that would give us LSI Logic. And 8 would be 5 plus 3, so that'd be General Electric. Now we need to do the number of combinations here, and so the number is 10 as far as the number of stocks, and then we're going to choose 3 of those. So it's kind of a uh, just a combination with choosing 3 out of the 10. We just plug that into our combination equation, and once we do that, we end up with 120 as far as how many different simple random stocks can be selected. All right, number 10, indicate which of the following situations involves sampling from a finite population and which involves sampling from an infinite population. In cases where the sampled population is finite, describe how you would construct a frame. So A, obtain a sample of licensed drivers in the state of New York. Well, there's only so many drivers that are licensed in New York, so that would be a finite population. And the way we could do the frame is to construct a list by obtaining a list of licensed drivers from the New York State's Driver License Bureau. Now, obtain a sample of boxes of cereal produced by the Breakfast Choice Company. Well, while it seems like it might be a finite population, there's just so many of them that it's going to be pretty much impossible to count them all. So that would be an infinite population. And we're going to be sampling from a process, basically. It's just going to be a continuous process just going on and on and on. And so the process is the production line producing the boxes of cereal. Now C, obtain a sampling of cars crossing the Golden Gate Bridge on a typical weekday. Well, again, while this seems like it's going to be just a typical finite number, since it's over a period of time, there's not exactly the same cars each day. It's kind of an infinite population, and because you're sampling from a process, just people driving by, and so it's just one generating arrivals at the Golden Gate Bridge. Now, D, obtain a sample of students in a statistics course at Indiana University. Well, this one definitely is finite population. And basically, we're just going to get a list of the students enrolled in the course from the professor. E, obtain sample of the orders that are processed by a mail order firm. Again, that's just going to be an infinite number of orders that are going to happen. It's going to be a process, and so it's just one generating orders for the mail order firm. Now, if I have a survey question for a sample of 150 individuals yielded 75 yes responses and 55 no responses and 20 no opinions, what is the point estimate of the proportion of the sample population who responded yes? Well, yes was 75, so the proportion is 75 out of 150, and so you would write it, the p-bar equals 75 over 150, or that's just 0.50. Now, those that responded no, well, that would be 55 divided by 150, or 0.3667. You could do the same thing, take 20 divided by 150, and get your answer there to get the proportion. That would be no opinion. Okay, here we have Business Week published information on 283 equity mutual funds. A sample of 40 of those funds is contained in the dataset mutual fund. Use the dataset to answer the following questions. develop a point estimate of the proportion of the Business Week equity funds that are load funds, develop a point estimate of the proportion of funds that are classified as high risk, and develop a point estimate of the proportion of funds that have below average risk rating. So we really have to look at our data here. And where did my data go? There it is. All right. So basically these three columns were what we're given. So we have the fund, if it's load or no load, and then the risk level. And so what we need to do is first we have to kind of figure out how many of each items we have. So what I've done is kind of said, okay, we're going to find out the number of load, the number of no load, and all you do is you do a count if. So I'm going to count if, and I highlight all the data that we're looking at, and then I look at the ones that are going to be load, and that gives me 18. Doing the same thing with no load, basically, I have 22 of them. Now with risk level, I do the same thing, except now I'm going to look at average, low, high, and very low. So doing the same thing, I get here 16, 12, 6, and 6. All right, so if we go back to our PowerPoint slide, and is this the one that's running? Okay, yeah. So 18 of the 40 funds in the sample are load funds because we had 18 of them we found in our table, and there was a total of 40, so 18 divided by 40 is 0.45. Now, how many were high risk? Let's see if we can show you that. High risk, well, there were 6 out of the 40. And then the next one is going to be how many are below average. So that's going to be our low and very low, so 12 plus 6, which is 18. So first our high, that was the 6 out of 40, so that's 0.15. And then we had the below average, so that's the low and very low, which I said was 18. Divide that again by 40, and we have 0.45. So that's developing our point estimates for the proportions of the different items that they asked for here. All right, the next one, a sample of 426 U.S. adults aged 50 and older were asked how important a variety of issues were in choosing from whom to vote for in the 2012 presidential election. A, what is the sampled population for this study? Well, that's just going to be the 426 U.S. adults aged 50 and over. B, Social Security and Medicare was cited as very important by 350 respondents. Estimate the proportion of the population of U.S. adults aged 50 and over who believe this issue is very important. Okay, so we want to have 350, we want the proportion out of the total 426 that were sampled. So that's 350 over 426, which is 0.8216. Okay. Next, education was cited as very important by 74% of the respondents. Estimate the number of respondents who believe this issue was very important. Well, 74% of the total 426 that were found, we just take 0.74 times 426 and we get 315. Okay. Now, the next one, job growth was cited as very important by 354 respondents. Estimate the proportion of U.S. adults aged 50 and over who believe job growth is very important. Well, again, we just take 354 divided by 426, and it's right here, 0.8310. And a final question here. What is the target population for the inferences being made in parts B and D? Is it the same as the sampled population you identified in part A? Suppose you later learned that the sample was restricted to members of the American Association of Retired People, AARP. Would you still feel the inferences being made in part B and D are valid? Why or why not? So this is a multi-step problem. So then inferences made in part B and D, which are this one and this one, are being made about the population of U.S. adults who are age 50 or older, which is what we said in the first question, part A. Okay. So that's our target population. Now the target population is the same as the sampled population, which is good. Now if the sample population was restricted to the AARP members who are 50 years of age or older, then our sampled population would not be the same as our target population, because now we only have that they have to be the AARP who are 50 and older, and that might not be the same as the ones that are sampled who are just 50 or older. Okay, so the inferences made in Part B and D would only be valid if the population of AARP members age 50 or older was representative of the US population of adults age 50 and over. But if it wasn't, then we can't say that it was. So that would be our whole key here. So you kind of have to think about how things are in situations like that. And that's all the questions I have for this week. If you have any questions, please feel free to contact me. Thank you.